All right, so in the last unit, we're going to talk about some different topics that are not as much related to what we have been doing. So we're going to have a change of pace here. So in Chapter 9, we're going to talk about hypothesis testing. And then at the end of the unit, we're actually going to run back and do Chapter 4. Let me see if I can focus this a little bit better. Okay, so we're going to figure out how to set up an experiment/test, and then how to prove a hypothesis or possibly disprove it. And in statistics, we usually use two statements to set up this test. The first one is called the null hypothesis. Null means nothing or zero usually. So the symbol or the notation for that is actually H sub 0, H for hypothesis, 0 meaning null. And the null hypothesis is a statement that the parameter, which is just something we're measuring. So the null hypothesis is going to state a hypothesis that the value we're measuring is equal to a specific value. Okay. And then alternately, we're going to have an alternate hypothesis. And we call this H sub 1. So there's only two options here, the null hypothesis or the alternate hypothesis. The alternate hypothesis basically goes opposite of what the null hypothesis said. So it states that the value of the parameter, which just means what we're measuring again, somehow differs from what we expected it to be in the null hypothesis. All right, so the null hypothesis is kind of general. It's always kind of the same look. But the alternate hypothesis has three kind of types. The first one is called a left-tailed hypothesis. Okay, so think about numbers on the number line that are to the left of another number. So in a left-tailed test, it states that the parameter is not what we said in the null hypothesis, because that's what the alternate hypothesis is going to say, but it's going to say that it's less than, so I'm going to underline that, the value specified by the null hypothesis. So here's an example of a left-tailed test. So let's say you're measuring something. Let's say you're measuring average temperature in Colorado in March, okay, or maybe February. And let's say that our hypothesis is that that average temperature is going to be 35. Okay, so our null hypothesis always states that the mean is something or a value is equal to something. But then we have to have an alternate, because what if our hypothesis is wrong? And in a left-tailed test, that alternate would be, hey, it's not 35 like we thought, it's something less than 35. Okay. So notice that doesn't cover all the options, but this left-tailed test is only concerned with things that are to the left of the value that we thought it was going to be. So not surprisingly, we can have a right-tailed test also. And a right-tailed test just states that the parameter is more than the value specified by the null hypothesis. That should be easy to remember because things that are more than are usually to the right of a value. And then the third and final type of alternate hypothesis is called a two-tailed test. And the two-tailed just means that the alternate can be either side. So it basically states that the parameter, oh, let's go back. Sorry. I wanted to give you an example of the right-tailed. And there's no way I can squeeze it in there. So with the right-tailed test, we might say, hey, we think the average temperature is 35. Notice the null hypothesis of both are the same. But in the alternate hypothesis, if that doesn't turn out to be true, then maybe the temperature is greater than 35. Okay, so that's the only difference between the two is less than, greater than. All right, so now let's go back to two-tailed. So in this one, we would catch values that are either less than or greater than. So it's just basically values that are not equal to the value specified by the null hypothesis one way or the other. So this type of test is for when, you know, you don't really care whether it's bigger or smaller. You just want to know if the null hypothesis ended up being true or not. So that would be, hey, we think the average temperature is 35, but the alternate is that it's something other than 35. Okay, so that means not equal to. Okay, so we're going to read through some scenarios and learn how we can set up a test of our own. So when you buy products at the grocery store, like cereal, the FDA makes them label how much product is in that box. You know, so they couldn't sell you a big box with very little cereal in it. They have to actually legally tell you how much cereal is in there. So let's say we're trying to buy a box of cereal and it says it contains 20 ounces. But in reality, there's going to be some imperfections in weighing. So some boxes are going to have more than 20 ounces and some boxes are going to have less than 20 ounces. Because even though machines are filling those boxes, more than likely, there's errors in those programs. So let's say that an inspector thinks that this cereal company is being less than honest. He thinks that there's less than that. And so I want you to see if we can state the appropriate null and alternate hypothesis. By the way, when you have plural hypothesis, it's hypotheses. So that's how that works. So if you read through, probably important to note is that he thinks that there is less than what it said. Okay, which means we do have a left-tailed test. And so we need to learn how to set up our null and alternate hypothesis. The null hypothesis will be the same no matter what kind of test it is. So with the null hypothesis, you start off with, we're pretty sure that most boxes are going to average 20 ounces because that's what the label says. But the alternate hypothesis is what the inspector actually believes is happening. He thinks that there is something less than 20. Okay. So that's it. In this section, we're actually just learning how to set up these tests. We're not necessarily learning how to perform these tests. We'll start doing that in the next section. So for now, you just need to learn how to read through the word problems and figure out what the wording is telling you. All right, so let's look at this. Let's say last year the mean monthly rent for an apartment in a certain city was $800. But let's say that a real estate agent who's trying to rent these places believes that the mean rent is rising or is higher this year. And so I want you to state the appropriate null and alternate hypotheses. So first we want to figure out which type of test it is. So if you read through, you need to pay attention to whatever the person thinks is happening. So he thinks that, or she thinks that it's higher this year. Okay, higher means the same as more than. So this is going to be a right-tailed test. Which only means a change for the alternate hypothesis. So the null hypothesis is what is being stated to be the truth, which is that the mean is 800. But the alternate hypothesis, the thing that she believes might be true, is that it's something greater than that. Notice we're not being very specific, right? We're just saying we don't know what it is, but we think it's bigger than 800. All right, so let's do a third one, and then we're going to kind of talk about how we will perform the tests in the next section. So let's say the scores on some test have a mean of 70. But some changes or modifications have been made to the test. And due to that, a teacher believes that the mean will be changed. And again, I want you to state both hypotheses. So when you set up a hypothesis test, you always start here. It's always H sub 0, H sub 1. Okay, and your H sub 0 is always a very simple statement. We're just going to say, hey, we were told the mean was 70, or we think the mean was 70 originally. But then a teacher thinks that the values may have changed. Okay, so notice it doesn't say is less or more or anything like that. So it just means they think it's something different. Okay, and I didn't write this, but notice this would be a two-tailed, because we're saying that it's either equal to 70 or it's not. So those are the three types of alternate hypotheses. Okay, Null hypotheses are kind of boring. They're always kind of the same. So a hypothesis test not only is going to determine kind of if we're right or wrong. So it's kind of not like science where you test the hypothesis and you're just like, yes, it's true, or no, it's not true. It's actually going to have more than that. It's actually going to come up with a probability of how likely it is that it's true. In other words, how reasonably assured can we be that it's true? So here is the process for a hypothesis test. We first assume that the null hypothesis is true. In other words, we assume that the vanilla, easy statement that we said originally is true. Okay. And then if the data shows evidence against the null hypothesis, in other words, if we have evidence to show that our null hypothesis is false, then we reject it. And then we alternately believe the alternate hypothesis. In other words, we assume that H sub 0 is true. If it's not true, then our backup is true. Okay, our H sub 1 is true. Okay, so here, I'm going to put a star here. These are actually really important statements. So if we reject H sub 0, then we conclude that the alternate is true. But it doesn't work the other way, and we're going to talk about what that means in a minute. If we don't reject H sub 0, then the null hypothesis might be true. So in logic, it's a lot easier to prove something false than it is to prove it to be true. Okay, if you prove something false, you only have to show that it's false once. If you want to show something is true, you have to show that it's true all the time. So it's a little more of a challenge to prove something's true. So this means that if we don't reject H sub 0, it doesn't actually mean that it's actually true. Think of it like if you've ever seen a court drama, you know, we have two verdicts when we are criminally trying someone, right? We have guilty and then we have not guilty, but not guilty does not mean innocent, right? Not guilty just means there wasn't enough proof to show that the person did whatever we thought they did, right? So in a court, you know, if they're guilty, then that's kind of it. But if they're not guilty, it means they might be innocent, but they might not be, okay? So that's kind of how I think of that. All right, so let's look at example 1. So example 1, remember, was the cereal box example. So we were told there was 20 ounces of cereal in the box, but the inspector thinks, hey, I think there might be less than that. And let's say that the inspector does not reject the null hypothesis. Okay, so let's talk about that with reference to example 1. That means he's going to assume that there is 20 ounces of cereal in the box. And when he tried to show that, he was not able to reject that. In other words, he was not able to find proof against there being 20 ounces in the box. Okay. So basically, what's the conclusion? Basically, his test is inconclusive. And we're not saying there is 20 ounces or there's not, basically. There's not enough evidence to show. In other words, he did not reject his null hypothesis. So, to use our court example, he kind of found the cereal to be not guilty, right? Which doesn't mean the cereal's innocent. It doesn't mean that the cereal manufacturers didn't lie. It just means that we weren't able to prove that they did lie about what was in it. Okay, so when you don't reject the null hypothesis, your test is inconclusive. Okay. All right, by the way, we won't do another example, but if he would have rejected the null hypothesis, then he could have concluded that yes, the cereal box has something less than 20 ounces. We don't know how much it has, but you know, there's something going on there. All right, so as we set these tests up and as we try to find how likely they are to be true or not, there's always a possibility of error. And you're going to need to know the difference between the two types of error we have. All right, so what we're going to do for this is we're going to set up a little chart. So we're going to compare the decision with the reality. So set up kind of a chart that looks something like this. And then reality is going to be up here. So your only two decisions are that you reject H sub 0 or you do not reject H sub 0. Okay, notice we never accept H sub 0 because it's not enough to prove. It's inconclusive. And the decision, the reality is one of two things. Either in reality, our null hypothesis is true, or it is not. Okay. So rather than giving you definitions of these two types of errors, I'm hoping to kind of illustrate it in this table here. All right, so first let's find the errors, or first let's find the decisions that would be correct. Okay, let's say we rejected H sub 0. Okay, well, if we rejected H sub 0, we would hope that H sub 0 is false, right? That would be the correct decision. Okay, so this would be like the person's guilty, right? And we found them guilty. Okay. Notice that if H sub 0 is true, we should not be rejecting it, right? So this is also a correct decision. So we have two correct decisions and we have two errors, okay? So notice this type of error is we reject something that actually was true. So this would be like you found a defendant guilty, but they were actually innocent. They were actually telling the truth. Okay, and this is what's known as a type 1 error. So when you reject something that should not have been rejected, it's a type 1 error. Okay. Notice the decision here, we did not reject H sub 0, right? We did not find them guilty, okay, but they were false. They were telling a lie or something like that, right? So we should have rejected them, but we did not, which means this is a type 2 error. Okay, so a type 1 error is rejecting it when you shouldn't have. Okay, so maybe we'll write that down. So a type 1 error is rejecting H sub 0 when you shouldn't. Whereas a type 2 error is not rejecting H sub 0 when you should. Okay, both are the quote wrong decision, but the error is different. All right, so for the last example in this notes, we're going to see if we can differentiate between those two types of errors. So I want you to find the type of error, if any. In other words, remember, sometimes we're making the right decision, right? We shouldn't always assume that there is an error at all. All right, so let's look at 3 scenarios. The first one is a test is made and our null hypothesis is that the average is 5 versus the alternate hypothesis says that the mean is something less than 5. So the true value of mu is actually 5, and H sub 0 is rejected. So first we need to figure out, is there an error taking place or not? Okay, remember the process is we assume that the null hypothesis is true unless we have proof otherwise. Okay, so we were assuming that the mean was 5, okay, but we rejected it in the end, right? But then in the end, it was actually 5. So notice we rejected something when we shouldn't have, so that's a type 1 error. Okay, in other words, the average was exactly what we originally thought, so we shouldn't have been rejecting it at all. Okay. Let's look at scenario B. A test is made of H sub 0 where mu is 20 versus mu is not 20. Okay. By the way, this was a left-tailed test. This is a two-tailed test, right? So the true value of mu is actually 25. And let's say that H sub 0 is rejected. So we thought the mean was 20. The mean ended up being 25, and so we rejected it. Notice that's completely the logical right decision. So there's no error here. This is the correct decision. Okay, the mean did not end up being what we thought it was of 20, so we rejected the null hypothesis. By the way, notice, it doesn't mean that we knew that it was 25. We just knew it was something other than 20, right? And so last one, let's say that we have a test where we think the average is 63 versus a right-tailed test where we think it's something greater than 63. And the true value of mu is 75. And H sub 0 is not rejected. By the way, notice we're always only rejecting H sub 0 and then by default saying something about H sub 1. Okay. All right, so we think the mean is 63 versus something bigger than 63. Okay, in the end, it turned out to not be 63, right? Something bigger than 75. Okay, so, or sorry, something bigger than 63. So we should have rejected this because it was false, but we did not reject it, right? So we did not reject something that should have been rejected, which is a type 2 error. So remember, type 1 errors are finding someone guilty, right, when they were actually innocent, okay? Whereas a type 2 error is not finding someone guilty and they actually were guilty of whatever it was, right? So like the, Casey Anthony's of the world, right? All right, so make sure you do the homework for this. I would really strongly suggest you try the homework for this before moving on to 9.2 because you need to kind of get the taste of these, and this is probably something brand new that you've never really learned before. So I'd like you to maybe try to do the homework kind of on track like you're supposed to. So I'm not going to change the due dates for that, but my intention for you is that you watch a lecture video and you do the associated homework, and then you watch the next lecture video and you do the next homework, and so on and so forth.